Hi guys, we're going to be looking at Units 9 review packet, focusing on the circle problems so that you may practice prior to taking your Unit 9 assessment for Quarter 4 recovery. We're going to start with circle problems, but you'll notice that off to the side, any problems that we do that are circled have very similar problems within the packet that you can practice if you feel as though you need more time or more practice before taking your test. If at any point you feel like you need to pause the video, rewind, or just pause it for a second, that's fine. Remember, you're doing this to help you recover Quarter 4. So this first one says our directions say to evaluate each expression. So what that means to do is that we need to set it equal to x. There's something called the loop method, L-O-O-P, loop. We start in the basement with a base of 2, we loop to the outside, and we come in to the number in the middle. So we rewrite this as 2 raised to the x equals 64. So you can see that I just followed that loop around so that I could rewrite it in exponential form. Starting in the basement with the 2, loop out to the x, so 2 to the x equals 64. From here, we use the method of common bases to help us solve this. So we keep the 2 to the x, but we want to rewrite the 64 as a base of 2. So in your calculator, you're typing in 2 to the third, 2 to the fourth, 2 to the fifth, until you find what number you can raise 2 to, in order to get a 64. So try that in your calculator. Once you have it, put it on your paper. So I found 2 to the 6th power gives me 64. From here, because my bases, the big 2's, are the same, I can actually cancel them out. So now we're left with x equals 6. If you need another practice problem, try number 2 right now. Otherwise, we're taking a look at number 3. Very similar problem, except instead of just a big regular 64 or a big regular 25, in this case we have a 1 over 25. But the method is still the same. Start by setting equal to x and then loop. Try to write down what you're going to get once you loop on your own, please. So now we have 5 to the x equals 1 over 125. Nope, just kidding. It's not a 125, it's just a regular 25. Sorry. Okay, so now we're still going to use the method of common bases. 5 to the x equals 1 over 5 to some power gives you 25. 5 to the second gives you 25. But it's on the bottom of a fraction, so if I want to bring it to the top, we have to remember that when we move it up top, we cross the line and change the sign. So we have 5 to the x equals 5 to the negative 2 now. Cross the line, change the sign. From here, cross off your big bases because they're the same on both sides. So now we have x equals negative 2. If you have a fractional number that you are trying to raise to powers, your value should always be negative. The next part we're going to look at is expanding logs. When we expand, we should end up with an answer that has more than one log. Like literally the word log should be written more than once. When you condense, you go from many logs down to one log. So you can see here that we have these little dots meaning multiplication. With logs, multiplication gets changed to addition, and division gets changed to subtraction. You can see that a big division bar kind of looks like a subtraction sign, so those get paired together. Then addition and plus get paired together. And vice versa, these arrows can go in the opposite direction if you're asked to condense, which we will be in just a few minutes. So I see 2 multiplication symbols in number 5, which means that I should have 2 plus signs in my final answer. And because there are 1, 2, 3 variables, x, y, and z, that means I should have 3 logs in my final answer. So we start with log base 4. You leave the base 4 there. You don't touch it at all. You just keep it. Of x. Whenever I say of, that means I'm opening up a pair of parentheses. Plus log base 4 of y plus log base 4 of z to the 6th. Now when we're expanding, we can't just leave it like that. Our last step is to get rid of any exponents, and exponents get moved to the front of their own individual logs. So now we have log base 4 of x plus log base 4 of y plus 6 log base 4 of z. Box it in, and that's your final answer. Again, the 6 only got moved to the front of log z. Number 7 has a question where we have an exponent on the outside of parentheses. Now when I taught this to you guys, I taught you to move the exponent first, and then we'd have to distribute it after. Craziness. I'm going to teach you a slightly different way that I think might be a little bit easier. What you're going to do is take this exponent of 5 and distribute it immediately to each of the variables inside the parentheses. So now we have log base 9 of x to the 5th over y to the 20th. When you distribute it to a power to a power gets multiplied. So now, because of this division, that changes to subtraction. Because I have two variables, that means I have two logs. So I have log base 9 of x to the 5th minus log base 9 of y to the 20th. But again, we don't like exponents, so what we do is move them to the front of their own individual logs. So we have 5 log base 9 of x minus 20 log base 9 of y. Box it in, and that's your final answer. If you need more practice with division of logs, perfect opportunity would be right here with number 6. Taking a look at number 9 and 10. It says to condense the logs. That means we go from many logs into one log. So you know how moving the exponents was our last step in the last example? We move the little 20 into the front, move the little 5 into the front. Well, now our first step is to move those front numbers and make them as little exponents. So the only big number in front I see is a 6 in front of the log of z. So everything else stays the same. Log base 6 of x plus log base 6 of y plus no more big 6, so we have log base 6 of z to the 6th. Now these plus signs gotta go. Because there's two plus signs, that means I'm changing to two multiplication signs with just one single log. So I need a multiplication dot, and in here we start with the x, we move to the y, and then last but not least, z to the 6th. Go from many logs, multiple logs, down into one log. Take a look at number 10. Think about what your first step would be if you have a big 15 and a big 5. Got to move them out of the way first. So we have log base 7 of u to the 15th minus log base 7 of v to the 5th. This subtraction sign is telling me to use some big division between our variables. So we have log base 7, big division. The first thing that we come across goes up top. The second thing we come across goes on the bottom. So we have u to the 15th up top and v to the 5th on the bottom. Box it in, and you're good to go. If you need more practice, you can either go down to number 11 or 12, depending on which one you think you need more practice with. Don't be scared if you try number 11. The 1/3 is treated just the same way as any other big number. Alright, flip it over so we can get more practice with solving equations now. So number 13 says to solve each equation. There's two different methods that we have to use when we're solving equations. One of them is to cross off logs on all sides of the equal sign, and the other one is to use the loop method. If you result an equation that has log of something equals log of something, Your method is to cancel them and set your somethings equal to each other. If you end up with log of something equals a number, your method is to loop. So again, log on both sides, cancel them out. Log on one side, loop. But before you can cancel or loop, you have to condense the one side. So we have log base 9 of x plus 10 plus, big plus, log base 9 of 4. The plus, remember, addition changes to multiplication. So now we have one single log, base 9, of 4 times x plus 10 equals log base 9 of 79. Now you might be wondering, why didn't I put the x plus 10 first and the 4 second? Because that's the order it was in number 13. And yes, that's true, but because I'm multiplying, I like to put the single thing first, the monomial first, and then the x plus 10, the binomial second. Because I see logs on both sides, both with the same base, log base 9, they get to cancel. But they don't get to cancel until you have condensed. So now we have 4 parentheses x plus 10 equals 79. From here, you're going to distribute and solve just like a normal equation. If you need more time, just pause the video. I've got my work shown here, but your answer should be choice A. Number 15, same idea. We're going to start by condensing the left-hand side. I see a plus sign, so that's going to change to multiplication again. So we have log base 6, parentheses, 9 times x minus 2. Make sure x minus 2 stays in its own parentheses so that way you don't lose it when you are multiplying. Because there's only a log on one side of the equation, there's not one with this 1 over here on the right side, my method here is to loop. I can't cross off the logs and I can't just stick one on the other side. It doesn't work that way. There's only one log given to me, and so now I have to loop. So think about the way that we looped on the front page. We have 6 to the first equals 9 parentheses x minus 2. 6 to the first is just 6. The 9 gets distributed, and from there you just solve like normal. If you need more time, just hit pause. Otherwise, you should have gotten choice A, because 24 over 9 gets reduced to 8/3. If you need more practice, go back to those questions on the right-hand side, number 14 and 16. We're going to take a look at the next page for a couple more solving questions with logs and then without logs. Number 19 is the same type of problem, except it's not multiple choice. But I do see a minus sign here. Minus, remember, changes to division. So when we condense this left-hand side, we now have division. Log base 7 with division. 9 goes on top because it comes first. X plus 6 goes on the bottom because it comes second. Still equal to 1. Now, because there's a log on just one side, think about what your method is. Do you cross them off, or do you loop? So 7 to the first is supposed to be equal to 9 over x plus 6. From here, because I see a fraction on the right side, I'm going to make the left side into a fraction by putting it over 1. Then we can simply cross multiply. When I cross multiply, I'm putting the x plus 6 in parentheses so that way I can distribute the 7. So the directions for these ones did actually say on the previous page to round to the nearest 10,000th. 10,000th is 4 decimal places. Point blank 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 blank. 10,000th. So this negative 33 over 7 now becomes negative 4.71429. And when we round 4 decimal places, the 2 must be bumped up. So x equals negative 4.7143. If you feel like you need more practice with this, you can go back to number 17, 18, or even 19. Nope, just kidding, we did 19. Or 20 is a good question for you. Otherwise, we're going to move into another topic, the last topic of this unit. It says, solve each equation and round your answers to the nearest 10,000th. So for everything that we've seen so far, we've at least seen the word log once. But in these problems, there's no word log. So what you do to both sides is put the word log in there. We call it logging both sides. Now, our goal here is to solve for whatever the variable is, whether it's n or r or b or x, whatever it is, our goal is to solve for that. So what we're going to do is take little exponents and move them to the front, kind of like what we were doing earlier. And when you move them to the front, it ends up being multiplied by its log. So in order to get this 5n by itself, I need to undo the multiplication that's happening by log of 20. So to undo multiplication, we do a great big division. They cancel out on the left side, but on the right side, this is what we're going to type into the calculator. If you have a TI Inspire, you're going to first hit Control and then the divide button. This will give you a fraction. From there, on the TI Inspire, you're going to hit Control and then the 10 to the X button. That'll bring up the log for you. You're going to skip the first box. And then in the second box, you're going to type in the number. Then you're going to go down, Control, 10 to the X again, skip the first box, then move over, type in the 20, and hit Enter. Again, this is the step or the process for a TI Inspire. So now we have 5n on the left side is equal to 1.47904. But remember, our goal is to solve for n. So now we have to get rid of the 5 by division. N equals 0.295809. Rounded to the nearest 10,000th, 4 decimal places. 1, 2, 3, 4, 8 looks to the 0 and stays. So we have n equals 0.2958. If you want another problem just like this, take a look at number 22 right now. If you're looking at number 22, just pause the video, because I'm going to move on to number 23. Very similar process. We have 18 to the x minus 10 equals 32. I have no logs anywhere, but what I can do is put logs on both sides. And we don't like exponents, so we take the x minus 10 and move it to the front. And when you move it to the front, make sure it goes in parentheses to be multiplied by a log of 18. The reason it should go in parentheses is because it has a minus 10 attached to it, and we don't want to just kind of lose that. Remember, your goal is to solve for x minus 10. At least the first goal is to solve for x minus 10. So we have to undo multiplication by log of 18 by division. They cancel on the left, and on the right is what you're typing into your calculator. If you need more time to type it in, just hit pause. I already have my answer key done, so I know what it is. I'm so special. I have 1.19906. And to get x by itself, we got to move the 10 away by adding it. 11.19906. 0 is my fourth decimal place, looks to the 6, and the 6 bumps it up. So we have x equals 11.1991. Box it in, you're good to go. If you want another problem just like this, try number 24. Otherwise, flip it over. We'll see one more type of example of this type of problem, and then you'll try your assessment. Number 27, it's hard to see on my video, but it is circled. We have a negative 8 times 14 raised to the m plus 10 equals negative 88. Now before, we would just say, oh, log both sides, move the exponent, blah, blah, blah. But before we log both sides, this negative 8 has got to go. You can see that multiplication little dot right there is telling me that the negative 8 is being multiplied by that 14 to the m plus 10 power. So in order to undo multiplication, we have to divide both sides by negative 8. So we now have 14 to the m plus 10 equals 11. Negative 88 divided by negative 8 is 11. From here, we get to log both sides. Again, the important step was to isolate the number raised to a power. So if you were looking at, say, number 28, you would have to isolate this 12 to the negatives 9k by getting rid of the 2 by subtraction in this case. So you'd have 12 to the negative 9k equals 91. From here, the process is the same. Log both sides, etc., etc. Move the exponent to the front. Be so cool like that. Don't forget to put it in parentheses. Times log of 14 equals log of 11. Your goal is to get m plus 10 by itself. So undo multiplication by division. Can you guys tell I love logs? They just make me so excited. M plus 10 equals, on the right side is what you're typing in. From there, get m by itself by subtracting. Remember, you can pause this video at any point in time if I'm going too fast for you. And then rounding appropriately. Gives you a final answer of choice B. If you want more practice with any of these types of problems, you see a whole page here, and I believe there's a whole nother page, and a whole nother page, and a whole nother page. There's a million pages. I'm just going to suggest that you do not go into questions 49 through the end, because those are a little bit trickier and not what you're going to see on the assessment. However, anything up to number 48 is fair game for your assessment. So if you need more practice, any of those would be great options for you. Good luck on your assessment. Remember, you can go back, pause, rewind, whatever you need to do. See ya.